11.2 Representing vectors. There are two ways that we may describe vectors at A-level: column vectors, which you've met when looking at translating shapes, and unit vectors, or IJ notation. Column vectors are written as one number above the other in brackets, where the top number represents the x component and the bottom number the y component. If we want to multiply a column vector by a scalar, simply multiply both the top and bottom of the column vector by that scalar. If we want to add two column vectors, we need only add the x components and the y components together to find the resultant. If we want to subtract, we can do that too. Example 6, and we're given two column vectors, A, 2, 6 and B, 3, minus 1. For part A, we're asked to find 1/3 of A. Well, 1/3 of A will be 1/3 of the column vector 2, 6. So we find 1/3 of the top, the x component, which would be 2/3, and 1/3 of the bottom, which would be 2. For part B, we're asked to find A plus B, which would be the column vector 2, 6, plus the column vector 3, minus 1. When we're adding, we add the tops to get 5, and we add the bottoms to get 5. For part C, we're asked to do 2 lots of vector A minus 3 lots of vector B. So that's going to be 2 lots of 2, 6, subtract 3 lots of 3, minus 1. First, I'm going to multiply the column vectors by the scalar to get 4, 12, subtract 9 minus 3. 4 minus 9 is minus 5, and 12 subtract minus 3 is 15. Unit vectors, which I'll now refer to as IJ notation, is a vector of length 1. A unit vector in the x direction is I and the y direction is j. Or I is 1, 0 and j is 0, 1. Any two-dimensional vector can be written in the form pi plus qj. For example, 5i plus 2j. That would be 5 in the x component, the I component, and 2 in the y component, or the j component, as we can see in this diagram here. Example 7. A equals 3i minus 4j and B equals 2i plus 7j. For part A, we're asked to find a half of A. A half of A will be a half of 3i minus 4j, which is going to be 3 over 2i minus 2j. For part B, we're asked to find A plus B, which is 3i minus 4j plus 2i plus 7j. Again, we can just add the I components. 3 add 2 is 5i, and minus 4 plus 7 is plus 3j. For part C, we're asked to find 3a minus 2b. So first, I'm going to find 3 lots of 3i minus 4j, and then subtract 2 lots of 2i plus 7j. If we multiply out, we get 9i minus 12j minus 4i minus 14j. We're left with 9i minus 4i, which is 5i, and minus 12j minus 14j, which is minus 26j. Example 8. I've been asked to draw a diagram to represent the vector minus 3i plus j. I've left the diagram from the textbook here. This is our starting point, and we go minus 3 left because it's negative, and then 1 unit up in the positive for j. For part B, it asks us to write this as a column vector, and we'd write minus 3, 1. Example 9, we're given three vectors A, B and C, and we're asked to find A plus B plus C using column vector notation in our working. Well, first of all, A would be the column vector 2, 5. B would be the column vector 12, negative 10. And C would be the column vector minus 3, 9. As these are all vectors, I should indicate that. Now, all I need to do is add those column vectors. So A plus B plus C would be 2, 5 plus 12, negative 10 plus minus 3, 9. And I'd get 2 plus 12 minus 3 would be 11. And 5 add negative 10 plus 9 is 4. Example 10, and I'm given two vectors A and B. I'm asked to find two lots of A minus B in terms of I and j. So that would be two lots of 5i plus 2j minus 3i minus 4j. Well, that's going to be 10i plus 4j minus 3i plus 4j. 10i minus 3i is 7i, and 4j plus 4j is 8j. Now I'd like you to work through exercise 11b. Any issues, please let me know.